We all agree that while push may be a great way to getting started, but propulsion is the only way to keep going. Distinguished delegates, colleagues from automotive industry, eminent speakers, fellow ICATians, ladies and gentlemen, a very good afternoon to all of you. I, Astha Divedi, on the behalf of International Center for Automotive Technology, Aspire Management in association with SANIS, let me extend a very warm welcome to all of you for this webinar on aerodrome lighting regulations and its impact on in the aviation industry and safety. International Center for Automotive Technology, ICAT, located in the Northern Automotive Hub of India, is a leading world-class testing, certification, and R&D service provider under the aegis of NATRIP, Government of India. Aspire is a technology platform. Aspire stands for Automotive Solutions Portal for Industry, Research, and Education. Aspire has taken an initiative of conducting the webinars on various topics, which is a part of celebration of Azadi Ka Amrut Mahotsav, which is 75th anniversary of our independence, of aiming to reinforce the Atmanirbhar Bharat in technology area. It is our privilege to have you all with us today for this webinar. Through this webinar, we have set a virtual stage to connect the industry and acquaint ourselves with emerging aviation lighting technologies and trends. For today's session, we have following speakers, Mr. Prateek Bajaj and Mr. Anshul Jan. Now, I would, for first presentation of the session, please join me to welcome Mr. Prateek Bajaj from Photometry Lab, ICAT.
Good afternoon, everyone. So from ICAT, I'm going to present you some basic information about the testing facilities and capabilities which we have at our center. So in ICAT, we have the testing capabilities as per NABL, ICAO, and BIS standards. So a group in ICAT named Electrical and Electronics Group consists of Photometry Lab, Automotive Electrical and Electronics Lab, EMC Lab, White Goods Certification and IT Products Lab, Prototype Development Lab, Component Evaluation Lab like CNG, LPG and HORN, and also Aviation and General Lighting Lab. In this lab, we have the testing capabilities to do the tests like dimensional tests, for IAS standard, FAA standard, and BI standards. Also, environmental tests such as high temperature tests, low temperature tests, thermal shock tests, salt fog test, corrosion test, EMI, EMC compliance, or electromagnetic compatibility, rain test, moisture test, also solar radiation test, dust test, which comes under IP test, humidity test, temperature cycling test. Also for structural tests, we can do wind test, jet blast, breakable coupling. Under electrical test capabilities, we have insulation resistance test, high voltage test, light fixture power factors, surge protection, light fixture flickers, total harmonic distortion, dielectric rigidity. In under functional test, we can do the photometric test, the chromaticity test, and the intensity ratios. Other tests can also be done like biological safety as per IEC 62471, accelerated life of luminaries as per IEC 61827, useful rated life of LEDs as per IEC 61827. So these are the testing facilities which we have in ICAT, like 2-meter integrating sphere for luminaries, 20-inch integrating sphere for LED modules, profile projectors, Type A goniometer, Type C goniometer. We have EMC chamber of 30-meter and for the vehicle test, and EMC chambers for 3-meter as component test. We also have vibration shaker, thermal shock test setup, HV and IR test apparatus, earth resistance test apparatus, leakage current test apparatus, climate chambers. We also have thermal test chambers, endurance chamber, and surge test apparatus. Apart from this, we have ingress protection against water, ingress protection against dust, the IPE test setups. We have weathermeter, we have a salt spray chamber as well. We have HFT test apparatus for plastic parts too. These are some aviation products which we have tested at our capabilities or facilities. These are the runway lights which we have done, and we have done more than this also. Thank you.
Thank you, sir. Now, for the second presentation of the session, please join me to welcome Mr. Anshul Jan. He has been a prominent personality in the sphere of aviation support, solution, and airfield ground lighting technology. He has a wide experience of over 15 years providing his services for heavyweights like L&T and Honeywell. Currently, he is the Sales and Marketing Director at Vardhaman Airport SLP. Sir, we welcome you all.
Thank you for the lovely introduction, and good afternoon to everyone here. And I would like to thank, before I start, I would like to thank ICAT and Aspire for arranging this knowledgeful session, which will increase the awareness about the airfield lighting regulations and its impact on the safety in aviation industry. So this is what we are going to talk about today. So before we start, we'll have the agenda. So first of all, we are going to talk about our organization, Vardhaman Airport Solutions, whom I represent in India in airports. We'll talk about the portfolio products, solutions and services that we provide for airports. Then we are going to talk about the aerodrome lighting regulations from maintenance point of view. So I'm sure many of you must be aware of airfield lighting regulations as per ICAO and FAA. But today we are going to talk about the maintenance practices, how to maintain those systems as per ICAO and FAA, and what do they say about maintenance, especially from photometric testing point of view. Then we'll start learning about what are the causes of degradation of these light fixtures on the airfield, and what causes them to fail, what causes them to degrade, and what are the solutions to prevent this degradation before it happens. And then we are going to learn about the benefits, how these photometric testing of the airfield lighting light fixtures will reduce the maintenance cost, how it will reduce the runway maintenance time, and how you can avoid instances of runway closure, because it will be a loss for the airport operator as well as airline. And then in the end, we'll have the question and answer session. So there's a chat box. You can write whatever you have questions, and we can take on individual answers after that. In case it is possible, I don't mind having questions in between the sessions, because it will make it more two-way communication. So I'll try to answer those questions also in between the session, if at all possible. So about us, so Vardhaman Airport Solutions is a premium organization providing quality products, solutions and services in primarily 4 fields, which is airfield traffic, air traffic management, visual aids, the gate management, ELV and security. So air traffic management is about the communication and navigation equipments which the ATC people use to communicate from the aircraft when the aircraft is in the air with the pilot. Then there are visual aids, which comprise of airfield lighting system, which helps the pilots to land and take off safely during night as well as low visibility period. Then the advanced visual docking guidance systems are used to park the aircraft in a particular parking bay. So there's no need of marshaller, which is used manually to park the aircraft. And then the photometric testing instruments are also part of visual aids. which are used to maintain the light fixtures, to maintain the color chromaticity and the photometric testing output and output candela of the light fixtures, and then the ELV, the extra low voltage system, which are used inside the terminal buildings. So I've just explained you what visual aids are. So on the top end side, you can see the inset lights, which are installed on the center of the runway or the center of the taxiway, based on the category of runway, whether it is Cat 2 or Cat 3, or if there's an emerging of taxiway with the runway. These inset lights are used so that the aircraft can roll over these. Then there are elevated lights, which you can see on the bottom, the end light, threshold light, and approach lights, and the puppy lights. So these are elevated fixtures which are fixed on the end, on the side of the runway and taxiway. So question arises, why photometric testing is required? So anybody here can answer why photometric testing is required? I can't see anything on the chat box. So anyway, so I'll answer the question in any case. So whenever I ask a question why as an engineer, I always think from the other person's perspective. Then you'll actually get the answer of the question. So airfield ground lighting is actually meant for the pilot so that they can land in the low visibility period or at night. So think from their perspective, if they are the pilot is deciding whether to land or take off, and they do some RVR calculations. So RVR means runway visual range calculations, the decision height and the visibility, whether it is 50 meters or 100 meters, and they do some calculations, RVR calculations, and they decide, okay, the visibility is say 50 meters, and now it's a Cat 3 condition, and I can land because the category 3 lighting is already installed. And if they decide to land and they see that the lights are not giving the light output as mentioned in the ICAO specification, so do you think they will be able to land? Of course not. So just to give more example and better clarity, I would like to show a video to show how exactly pilot sees from the cockpit when he's landing in low visibility and during the foggy conditions. So right now he's above the clouds and the fog. Now he has entered inside and he's trying to locate the runway. Then he sees SFL lights, sequence flashing lights. Then he sees the approach lights, then the threshold, the touchdown, the runway centerline, and the runway edge. So you saw how the runway, the light fixtures made it possible for the pilot to land in such a low visibility period. So now airports have a duty to give pilots the best visual cues they can when at the right moment when the pilot needs them. Because if you don't, they will not be able to land, and there will be runway closure or the flights have to be diverted, which is very costly affair for the airline as well as the airport operator. And ICAO study shows that human eye can only detect a loss in intensity once it is decreased to 30% of its original value, which means every time the aircraft lands, there will be some damages on the light fixtures, on the prism, there will be scratches on the prism, there will be some rubber deposit on the inset lights, and which cannot be detected by human eye. And also, if there's a orientation, if the toe angle is not proper, the orientation of the lights is not proper, then also human eye is not able to detect. So, and a lot of times the halogen lamps have to be replaced, and sometimes they change it during the maintenance. So some lamps which do not even need replacement, just because the group of lights gets replaced in the lamps, even the lamps which are working functional properly also get changed, which end up in higher maintenance costs. The only reason is because there is no photometric testing in most of the airports. So till 1980s, this test was performed by using a very basic lux meter. And now with technology getting advanced day by day and the traffic increasing in the airports day by day, uh, the technology has been adopted by mobile photometric testing device, which can be fitted on the vehicle. And this exercise of photometric testing of all the lights can be done on the runway within 15 minutes to maximum 30 minutes, which is quite good, especially for the airports like Delhi and Mumbai, where they cannot afford the runway maintenance, because if they increase the maintenance time, which means they will have less flights to be able to land and take off, and that means less revenue for the airport. So let's talk about, I have explained everything, but even if sometimes we as humans feel that even if we know everything technically, why to implement it? And that's where ICAO and FAA play a very important role as a regulator, and local DGCA authorities they have implemented CAR, which is quite similar to ICAO, to make sure that airports are regulated, and they are ensuring this photometric testing is done as per ICAO. So let's learn what ICAO says. So ICAO in their clause 10.5.1 says that a light shall be deemed to be unserviceable when the main beam average intensity is less than 50% of the value specified appropriate figure in Appendix 2. Now, what is Appendix 2? Let's go to Appendix 2. If I'm sure some of you must have seen it. So this is Appendix 2, figure A to 8, which is for runway end light. So the left figure that you see talks about the output candela, and the graph actually shows so every vertical and horizontal degree means 1 degree vertical and 1 degree horizontal, and this average intensity of 2500 candela is calculated based on the crossing points. You measure the output candela on these crossing points, and then you make an average output, and it should be 2500 candela. Not only that, at every point, the output candela should be not less than 1250, which actually means that it is not important. This average is only important, that you concentrate the light on the center part, and this and remaining of the sphere, the light is very less. So it has to be equally distributed also to make this average. And similarly for sphere 2, anywhere if the output candela is measured, it should be 250 candela, and the third most outer sphere, it should be 125 candela. This is for the runway end light only. Similarly, there are different figures for runway edge light, which is 10,000 candela. For approach light, it is 20,000 candela. For runway center line, it is 5,000 candela. Taxi weight is 200 candela. So every light has a different candela output. So the ICAO 10.5.3 talks about that the visual inspection and in-field measurement of the intensity, beam spread, and orientation of the lights included in the approach and runway lighting system. So intensity, I have actually explained how exactly the output candela is measured, the average. Then I have also talked about the beam spread, that it should not be concentrated on just one region to just make that average, and orientation. So basically orientation is on the right hand side on the figure. If you see, if the pilot is landing on the center of the runway, and the runway light fittings on the left hand side have to be towed a little bit towards the pilot. So if you see this figure, fittings on the left hand side have a tilted output towards the center to face the pilot, and fittings on the right hand side are tilted are towed at left hand side to face the pilot. So this is exactly that is also important, that orientation should be proper. Otherwise pilot will not, again, even if it is giving the right output, but if it is not giving the right output at the right angle, then also it does not make sense. It just imagine your situation driving a car, and if the light output is not giving on the road, do you think you will be able to see? You will not be able to see. So it has to be oriented properly then, so that you can actually see and visualize. Now the third point which ICAO talks about importance is that in 10.5.6 is that for a precision approach runway category 2 and 3, this in-field photometric testing should not be done less than twice a year for inset lights, and not less than once a year for the other lights, which means the elevated lights. So and a lot of customers, let me tell you, get confused that okay, we only need to do only twice a year for inset lights. So most of the airports are doing twice only, but it is actually not like that. So in case the traffic density is more in an airport, it means more landings. Like in Mumbai airport, there are 1,000 flights which land in a single day. So the degradation, possibility of degradation will be more in an airport like Mumbai. The pollution level in Delhi is high, so they again the photometric testing has to be done more frequently to check the reliability of the system. So this is minimum what is asked in ICAO, but as the airport differentiates from one depending on the traffic and the pollution index and the weather condition, it can be done once in a month or twice in a month also. And FAA, though it's a American standard, but still I would like to talk about what they actually say. So FAA demands photometric testing every once a month for inset lights. So imagine the airports in USA are compliant. So they see basically the photometric testing they do every month for the inset light fittings, which means they know the importance of safety. And they don't only do for safety, they also do because it reduces the maintenance time also. So it's a benefit for the airport at the same time. And they do it on all airports irrespective of the runway category, whether it is simple approach, cat 1, cat 2 or cat 3. And they have also kept this threshold level at 70%. So if the output candela in this graph, so as per ICAO, average intensity should not be less than 1,250, whereas in a FAA compliant airport, it should not be less than 1,750 because FAA has defined the threshold level to 70%. So if it is falling below 70%, you need to replace the light. So I hope that clears what the regulations talk about. Any questions so far? Again, I see a blank chat window. So I think maybe a question and answer session would be in the end would be the way to interact with the audience. So I'll take on with the next slide. So causes of degradation of the light fixture. So since again I cannot ask questions, so I'll straight away go to the next slide. So first, light alignment, and we'll talk about the other parts also, but I'll go one by one so that it is easy for everyone to absorb the information. So whenever the inset lights are installed, this core cutting, the figure third on the top shows the core cutting machine which is used to make that core. This is the core fourth where the core cutting is done to fix the shallow base in which inset light is fixed. The green color item is actually the shallow base. This is not the inset light, this is the shallow base. And this is after the shallow base is fixed, the inset light is fixed on top of it. Now, when you're installing the light itself, inset light, these jigs are used to align the light during the installation itself, because there's a chemical which is put, and if these jigs are not used, then they may not be aligned and oriented properly along with the runway, and you will see different angles of light coming out of inset light. So it is important that at the time of installation itself, this has to be properly aligned. And same is the case with CI boxes, which are used to house the isolating transformers, and the elevated fixtures are fixed on top of it. So they also should be, the level should be measured, that they should be aligned properly along with the runway, because if it is tilted, the light also will be tilted after that. And this is during installation, but also once these inset lights are fixed, then there are certain toe angles which are mentioned in CAR ICAO, and those toe angles also have to be fixed along with the alignment tools. So there are certain tools and equipments which are given by the manufacturer, so you can align the tool and the light fitting as per the toe angle as per the regulation. Now, some manufacturers have that that toe angle fixed automatically in the light, whereas some manufacturers allow that to be changed by a tool. So it depends on which manufacturer you are taking the light from, but you have to make the alignment properly. Then the second reason for the failure and degradation of the light output is the cleaning of lights. So I have seen a lot of airports, there are a lot of contaminants which go inside and outside the fitting. So let me give you one example, because there are many examples and we cannot take all of them. So this is a typical inset light which is installed on the runway, and because the aircraft is going on top of it, and every time the aircraft presses brakes, 1.5 pounds of rubber is removed from the tire every time it presses the brake, every time it lands. So you can imagine that amount of rubber gets deposited across the inset fittings, and they are actually silver, and now they have become black. Why? Because the rubber got deposited, and because these are halogen fixtures, they generate lot and lot of heat. And when the heat is generated, then the rubber gets deposited on the prism, which you can see in the second figure. It gets cooked, and you cannot remove it by a column or just a or water. So it has to be done by a proper tool. So there's a special tool used to clean the light. So third figure, if you see, so we have actually cleaned that light, and now it is becoming, the prism is becoming transparent, and now the light can come out. So this has to be done on the field, because if you don't, the fitting will be like this. So even if you have installed the light, there will be no light output, and pilot will not be able to see this light. Third reason is the torque of light. So this is very, very important from the safety point of view. So in the second figure, if you see, there's a torque equipment, digital torque equipment. So there are two bolts which are used to tighten the inset fixtures. And if they're not tightened properly at the right torque level, then they become loose and they are not oriented properly. On top of that, if in case it is loosened a lot, then because of the vibration of the aircraft, then these fixtures might even come out along with the aircraft tire, which is a very, very safety hazard. So how will you know that they have been tightened properly? So this digital torque actually helps to not even tighten the bolts, but also record all the readings which you are using to tighten these bolts, and everything will come in the tablet. So one person is holding the tablet, so every time this equipment is used, these readings go in the tablet, and it will record how many fittings have been tightened, and along with the location of the light fitting also. So the second figure, the fourth figure is basically the cleaning of the light which is happening. Third figure is basically the cleaning equipment which is stored on the back of the vehicle. And fifth figure is basically a portable photometric machine. So wherever you feel the in-field photometric testing cannot be done on the fixed on the vehicle, you can use this portable machine also. And the first figure is very important, the gasket. So one important failure again of the light output, the reason for degradation is the damage of the gasket also, because the water, if water ingress happens in the light fixture, again the light output will not give the right output as per ICAO. The other reasons are failure of the lamps, damage of the lamps, you have to replace the lamps. Then there are some prisms and filters also get damaged. So consider this example, like if you see a very old car and see the tail light or the red light and the yellow light on old cars will be little different when you buy a new car. Why does it happen? The reason is this only, because over time the filter, the color filter gets actually degraded along because of the weather outside. So in case the filter is not giving the right color, then the right amount of color output also will not come. And same is the case with prism also. So prism, whenever the flights are landing on the lights, the prism also gets scratches, and if they have too many scratches, then again the light will not come out. Then there are other reasons also, like power supply issue. So there are a lot of times when, if proper maintenance is not being done at an airport, then the output current of the CCRs is not calibrated to 6.6 ampere. And if it is not 6.6 calibrated, is less than 6.6 ampere, again the light output will change, because if it is showing that it is 6.6 but it is actually not, then the light output will also be not as per ICAO. So you have to make sure that you're calibrating all the CCRs on time as a maintenance activity. I have also seen that some of the airports are using wrong isolation transformers. Sometimes 200-watt lamps are used, and the isolation transformer is 150 watts. So in that case also, the light output will not give as per what is the light is designed for. And also the performance of single lamp monitoring system. So if the ASD, addressable switching devices, are not functioning properly and not communicating with the software in a Cat 3B airport, then also there's a possibility of the light output being incorrect. So what are the solutions? So I have explained you. I'm just summarizing everything. Whatever we have learned till now. So light alignment, how to check it is by alignment using alignment tools which are provided by the manufacturer. Then cleaning of the lights with a special cleaning equipment, which I will cover in later in the session in the presentation. Then the checking the torque of the lights. Again, I will talk about the product, how exactly it is done. So if the lamps are damaged, you need to replace the lamp. If the filter is damaged or prism is damaged, you need to replace the filter in prism. And once you do the photometric testing, you can do the photometric testing at the lab also, which you set up in the airport. And every time you open the fitting, the gasket should be changed so that there's no water ingress every time it opens. Then for right power, amount of power supply, to make sure that it is 6.6 ampere, you need to calibrate the CCRs as per the maintenance activities. And the capacity of isolation transformer, ideally it should match with the rating of the light fixture, or it should be more, little more, not more, not very much. So you can't use a 200 watt isolation transformer in a 100 watt light, because then there will be power losses in the isolation transformer. And if there's a wrong selection of product, obviously you need to change the product and replace it with the right product. Any questions so far? Okay, I don't see anything on the chat window, so I'm moving ahead. So this is a typical unidirectional sensor which is fitted on the vehicle, and this vehicle is used to test the photometric light output of the inset as well as elevated fixture. So the important thing to note is that the vehicle can go only where it is possible. So if you have approach light on the poles, then you cannot use this equipment to check the photometric on top of the pole. And because it is unidirectional, it is fixed on front of the vehicle. If it is a bidirectional sensor, it is coming from outside the vehicle. So this is a system that we provide in Mumbai airport, where it is fixed outside the vehicle, because it is testing the photometric. It is doing the photometric testing on both sides. So basically, the amount of time it will take for a unidirectional sensor, it will actually take half time, because in a unidirectional sensor, for a runway having centerline lights and edge lights, you will have to do the photometric testing by doing 6 times, because every light has a bidirectional. Whereas in bidirectional sensor, you just need to cover the runway in just 3 times. One is the edge, center, and then the second edge. So it will take exactly the half time. So if the unidirectional sensor is taking 30 minutes, this equipment will take 15 minutes. So again, there's a saving in the maintenance time for photometric testing. Again, this is cleaning equipment, torque equipment, and the photometric testing that we did in Jaipur airport. There are some site images. So once you're doing this photometric testing, the SOP has to be actually fixed by the airport. How exactly, what is the process and SOP you need to follow to do this photometric testing? Because it is not about just doing the photometric testing. It is about making sure that all the light fixtures are repaired properly on time, and then they are replaced with the faulty fixtures, and the faulty fixtures are again replaced with the new ones, or gets repaired, whatever issues they have. So first, before doing the photometric testing, you need to clean all the lights, because there have been studies which show that before you clean the light and you do photometric testing, there is a possibility more number of fittings will fail. So first, it is important to clean the light fixtures first, and then do the tightening of the bolts using the torque equipment. Then check the alignment by using the alignment tools provided by the manufacturer to check whether the toe angles are right or not, and then do the photometric testing. So after you do the photometric testing, whatever lights are failing in the photometric test, you replace it immediately with the right ones in on the field, and you bring all the faulty fixtures back in a photometric lab inside the airport, and you make sure that all the rectifications are done. And using a lab equipment, you again check the photometric of those lights, and then keep them back at the right place, so that they can be used again whenever some other light fixture is failing. So this is basically the SOP for the light fixture. And at the same time, you also have to make sure that CCRs are calibrated to the right current output from 2.8 to 6.6 ampere, and the isolation transformers also are of the right capacity. And once you do all these activities, you make sure that whatever report you're generating is submitted to the maintenance team, and then eventually to airport operator as well as DGCA. So now most important thing is a lot of people feel that this is a burden and this is increasing the cost of running an airport, which is actually not true, because unlike a security system, like after 9/11, you must have seen that all airports and five-star hotels started, rigorous checkings and frisking at the entry points. So which is actually not only adds to the cost of maintenance, but operations cost, but also increases the hindrance for the passengers. But in this case, it is not like that. So whatever investment is done by the airport to make sure that these photometric testing is done, it actually reduces the maintenance cost, because the technician needs to go to the runway not to visually check whether the lights are working or not. So he will actually check the report which light need to be replaced, and he will just go there and replace that light, and the problem will be fixed. So eventually the failure will not happen. This also will reduce the number of times. So all the airports have a fixed time of runway maintenance. So maybe once in a week or once in a month or once in a day. So if they have fixed a window of 2 hours, they can reduce that window of 2 hours to 1 hour, because they will be able to use that photometric testing report to check the photometric output and reduce that time. And the time they reduce can be given for any airline to land and take off, which means more revenue for the airport. And also it saves a lot of energy also. So now the question may arise, how does photometric testing save energy in an airport? Because light will be giving the light output the same. So a 200 watt will give 200 watt and consume 200 watt. So how does photometric testing will help to reduce uh, the energy consumption? So this is the answer of that question. So basically there's a study which shows that if the lamp is running at 6.6 ampere, and if you reduce this 6.6 ampere to 6 ampere, the lamp life increases by 500%. So typically a lamp lasts for 1500 hours. So if you don't run the lights at 6.6 ampere, you can increase the lamp value life, which means you don't need to replace the lamp frequently like you do. And why airports actually do it at 6.6 ampere? Because if it is not giving the right output and the pilot gives a feedback, I'm not able to see the lights, the only option for the airport operator in ATC tower is to switch the lights on 6.6 ampere, which is the maximum current output. Because they assume that at 6.6 ampere it will give the right maximum light output, so they will not complain about the visibility, low visibility or poor visibility. So even so, if you clean the lights properly, you do photometric testing, so you can run between 6.6 to 2.8 to 6.6 ampere, and you will increase the lamp life eventually, which will save the maintenance cost. So I've explained how a bidirectional sensor is actually sensing the light and why it is beneficial. So it's just a picture to show how exactly it is done on elevated fixture as well as inset fixture. So both the sensors take the input from the light, and it gives records all the data in a software to generate a report. This is how exactly the diagram is. So basically this is the sensor with the camera. This camera is actually fixed on the sensor to give output in this alignment monitor. Because the sensor is on the left hand side, you will not be able to see whether it is aligned properly on the lights or not. So this camera will actually show you whether your sensor is going on top of the lights or not, because it has to go on top of the lights to measure the photometric output. DGPS is basically used to identify the lights, and once you fix the coordinates for the lights, then you can easily know which light needs to be replaced. And this radar is basically used to measure the distance from different, because every light has a different distance depending on the category of the airport. So this measures the distance, and the output is given by Ethernet cable or Wi-Fi in the laptop inside the vehicle, which is doing the photometric testing. So this is how typically it looks like when it is fixed on the vehicle. And yeah, it can be done only at night, because in daytime there will be a daytime daylight itself. So the output output of the light fixture has to be measured at night only. So some of the customers had asked me one question, that this sensor has to be is moving on top of the runway end light, edge lights and the center line. But what about the threshold lights and the end lights? Because it will be very difficult because they are on the horizontal, they are on the width of the runway and not on the edge of the runway. So this sensor can be moved upside down, and then you can move the vehicle from one side of the runway to the other side, and you can do all the lights together. So this is just an image to show that. And these are the light outputs candela, which is as per ICAO and as per the runway category. And what are the 50% values? So basically you can fix these values at 50% is as per ICAO, but different airport operators can even fix this at 60%, 70% or 80% also, because FAA talks about 70%. So you can, the airport operator is not necessary for the airport operator just to follow ICAO only. They can put the threshold value at 60% also, and then the lights will show that they are failing. So how this equipment is used is basically the sensor is fixed on the vehicle. You select which lights to be measured, then you select the distance between the light fittings, then you drive over all the lights, and the software displays in real-time basis what are the results of each light. And then once you complete the lights, you name the function that, okay, you have covered this runway edge light or runway center line or taxiway center line. And this is how the report is generated individually for each light. So the average output of this particular light is showing 4,900. So basically it's a center line light and it's showing average value 4,900, maximum eclipse is 7,000, minimum is 1,900. It is 98% of ICAO. This is our GPS coordinates of the light fitting, which means the light is passed, which is why it is showing green in color. So if it is falling below 50%, it will show red in color. And when all lights are tested together, then you can fix that threshold level. So here the ones below threshold level of 50% are shown in red, and the ones which are shown in yellow are the ones which are passing the photometric testing characteristics as per ICAO. And these are all the lights. So you can individually select which light you need to see, and it will show the values. So this is an image to show that it is a very high definition ISO candela output which is taken. So basically on each light, when the sensor is rolling on the lights, every millisecond this output candela is taken, and there's around 11,600 samples are taken for each light. So it's a very high resolution, you can say, when the image is high resolution. So similarly, this photometric output excuse me, is 11,000, which means it is a very high resolution testing which is done for the light fixtures. So it cannot be incorrect. So you can compare with the ICAO standard also, and you can check the orientation of the light, which is on the right hand side or the left hand side, by visualizing this figure. And you can also see if it is not oriented properly, then you can also check the lamp, which is aging. So the red color is not shown, which is why the lamp is aging. So you need to replace the lamp. So you will know that before the light is actually failing, you can replace the lamp before it actually fails. Then the sagging of the filament is also an issue which can be detected in the software in the report. I have already told the importance of cleaning of the lights before the photometric testing happens. So this is a typical example in a Hong Kong airport where the lights were tested before they were cleaned, and then after the cleaning, the photometric testing was done again. And many of the lights which were actually failing before, I had actually passed the test. So it's quite evident that you have to clean the lights before doing the photometric testing. Now, this is a very interesting software on top of the photometric testing software, which is GAMES. So this software sits on top of it. If you have the latest state-of-art photometric system with a differential GPS, then you can map the lights on a Google map, and you can set 3 levels, which means green can be above 70% of ICAO. Yellow can be between 50 to 70%, which means they are degraded to some level, and you can take action to replace them, or correct the light fixture, whichever issues are there, and the reds are the faulty one which needs immediate attention. So you can categorize this on a Google map, and you can locate where exactly you need to go. So this is a GPS locator. So if you have that software, then you can even know where exactly you need to track the light, because airport is such a huge airport. It is very difficult for the maintenance team to find out where exactly to locate the faulty light after the report is generated. So this will help you to track the light so that you can reach the light in minimum possible time in the airport. So so this is the second level of stage of photometric testing, which means after you have tested the field photometric testing, you have removed the faulty lights, you have brought them back in a lab. So you can't correct the lights and then put them back on the field and then do photometric testing again, because it will take a lot of time. So for that, you need to have a workshop equipment also in a dark lab, where you fix this equipment, you bring the faulty lights, fix them with replace the gasket, prism, or whatever lamp, whatever is required in the light, and you test the photometric testing in the workshop equipment. And once they pass, you can put them back in the field whenever it is required. And the benefit of this photo workshop equipment is that automatically the light rotates whenever it tests from one side, the other direction also gets tested automatically. And for workshop equipment, there's a micro CCR also, because normal CCRs give 5,000 volt of output, which is quite hazardous for a human being. So it is better to have a micro CCR to test the lights in the photometric workshop. Then there are cleaning equipments. So one is dice and soda. Soda ice. Soda ice means soda ice. So basically, baking soda is used at along with compressed air at 7 bar pressure, and the lights, when it is pointed towards the light, it gets cleaned without damaging the light. So this is the basic functionality of the cleaning system. For airports which are in cold countries, you can use dry ice instead of baking soda. Then there's a system for PAPI. So a lot of times, I'm sure some of you might have heard about PAPI lights getting tested through a test pilot and a test flight, which is obviously a costly affair, because you have to check the PAPI by asking a feedback from the pilot. So why to depend on the pilot or the aircraft? You can have a system which can measure the angle on behalf of the pilot, and to give the output whether it is aligned properly or not. So this PATPI system is a camera-based system which actually tests not only the photometric testing, but also checks the elevation angle of the PAPI unit, average elevation angle of the unit, as well as PAPI bar. It also checks the horizontally of the color transition also of the PAPI bar, and it also checks the azimuth aperture and photometric diagram of PAPI unit. And the most important is color chromaticity, because there's a red color as well as there's a white color. So it also checks whether the red and the white color is as per ICAO annexure 14 or not, the chromaticity output. So I'm sure, like the diagram I had shown in Appendix 2 earlier on, that was for the intensity, but there's another diagram in ICAO which talks about the color chromaticity. So it's not that white can be of any white color or red can be of any color. So there's an area defined in this color chromaticity chart in ICAO, and these lights have to be tested whether the filters are functioning properly or not, because if the filter is not right, it will again give the wrong light output to the pilot. So this checks everything in a PAPI unit. So there's no need of a test pilot or a check pilot to check the PAPI. Then this is an important, again, equipment of Airfield signages, which checks the output candela of the signboards. So this is how some of the signboards, I have captured some images in some airports where you can actually count the number of LEDs, but as per ICAO, it should be uniform light output. So you can see the left-hand figure and right-hand figure, what is the difference. So basically, this equipment will check whether it is giving the uniform light output or not. And if it is not, it will actually say the compliance as per ICAO is no, because it will not only check the background as well as characters. So this left side is background results and right side is character results. So character is in on top. So in this panel, red is the background color and character is in white color. Then there's a pack apron where you can check the apron floodlights also, whether it is giving the right amount of lux at the apron area or not, and it will make a diagram to make sure that there are no black spots in the apron area, which is very dangerous for an apron area. Then there's a talk equipment, which I've already explained what exactly it does. So check. And the reason why it is used is because somebody in the field can tell that they have actually checked the talks, but how will you know they have actually checked it or not? Because you can't, the maintenance manager cannot be on the airfield all the time. So by checking that DGPS coordinates as well as the top figures of so many lights, the maintenance manager will know that it has actually been checked. Then there's a Mark 1 equipment. So instead of, because we are running out of time, so I like to show how exactly it is done using using an unmanned vehicle. So this equipment is basically an unmanned vehicle, and a tablet is controlling it, and it is testing all the lights. I'll show another video which actually shows how exactly it is done. So this equipment Mark 1 has talk checking, then photometric testing, cleaning, everything in one equipment. And that is a robot based equipment, and you can control this robot with a tablet. I think I will let video do the talking. I know audio is not visible, it's just for a visualization, how exactly the photometric testing is done using this vehicle. This tablet will get the immediate results, which light is failing, which is getting passed, and the report will be generated in real time. So there's a sensor which checks where exactly the nut and bolts are, and it will tighten automatically for all inset lights, and it will capture the results also. Then there's one more equipment which I don't have an image for, but yeah, for approach lights, you can see this one engineer, one of our technician is holding a sensor, basically multiple sensors, which are fixed on this equipment. And there's another engineer who's taking a tablet, and he's showing that capturing the light output in front of the approach light, and the result is captured on a tablet. So it's a very, very tedious task, because you can see somebody has to use stairs, go on top, fix that in front of the light, and then take the output, which is a very time consuming activity. Though ICAO talks about whichever light is possible, you should do it. But there's a latest technology by using drones. You can test the photometric testing of approach lights. So that's the latest technology in photometric testing, that drones are used to test the lights, and they have been doing the testing in Europe in some of the airports, and very soon you'll see the technology across the globe. So that's it. I think that ends my presentation. My coordinates are, you can send us email of any clarification you have, but I would like to ask questions if somebody has, and the panelists and organizers can tell if somebody has a question. So I'll try to answer to best of my ability.
So we have few questions from our audience.
Yeah.
The first question from Mr. Vishant Chaudhary. What is the IC dots? Please explain.
Sorry.
What are the IC dots? Please explain in brief.
IC dots. I'm not sure. IC dots. What they're talking about dots.
Okay, so next question from Mr. Sudhir Raheja. What should be the speed of car while doing photometric testing on highway?
Basically, it is not on highway, but yeah, it is done on the airport. So if the photometric testing is done on the runway, which because runway is straight, so the photometric testing can be done at 60 km/h. And on the edge light, sometimes you have to be very careful whether you're driving it on the edge light or not, because they are elevated fixtures. So ideally you can do it at 60 km/h, but it takes time to learn about how to drive on top of the lights, because for inset lights you can do it quickly, but for elevated lights you can do it at 40 km/h or 50 km/h. And for taxiway lights, because they are curves and you have to make sure that the sensor is going on top of the curves, you have to slow down and make sure that the sensor is going on top of the lights. So it takes more time in taxiway because of the curves. The speed should be around 15 to 20 km/h for taxiway lights.
Okay, next question from Mr. Prashant Mishra. Why we are not aviation lightning instead of halogen?
Why we are not?
Why we are not using LED in aviation lighting instead of halogen?
No, we are using. There are airports. We have private airports have already started using LED lights. We have fixed LED lights on. We have recently done a project in Kochi Airport last year, and now we have just finished, about to finish the runway in Bangalore Airport, the existing runway. So whenever you land, you will see LED light fixtures on the runway, because we are the ones who have fixed them. So I know. And Delhi Airport also, the fourth runway is coming up, which is being constructed by L&T. So by next year, you will see in Delhi Airport fourth runway project also, you will see LED lights. And Hyderabad also has converted into LED. So very soon, Airports Authority of India, which owns maximum airports, around 125 airports, will also follow the suit, and you will see that technology upgrade. They have already changed taxiway lights to LED. The only thing is Airport Authority of India has not changed runway to LED, but I'm sure with private airports already adopting the technology, this trend will be soon seen in airport authority also, airports also.
The next question from Miss Survita Saxena. While doing photometry check, can you see if towing angle is correct or not? If yes, how it will be presented in the report?
Look, in the report, the alignment good means whether the sensor is actually aligned while driving or not. So that alignment means the sensor alignment. It is not the alignment of the toe angle. For toe angle to check in the report, so somebody who is experienced in reading and analyzing the report has to visualize. So I can show from one of my slides. Probably then it will be much more clear. Yeah, so this is toe angle. So basically on the below image you can see it is going on the right hand side. So somebody has to visualize how the toe angle is. If you see the light is tilted towards right, so this is how you find out whether it is towed towards right, by visualizing the report. So it will not show, the report will not show at what angle the lights are fixed, but it will show visually that yes, they are towed as per the standard.
So next question from Mr. Dhusar Kumar Mondal. In the chromaticity diagram, what X and Y coordinates signify?
Okay, so there's a ICAO and FAA 14. I don't have it in my slide, but I have one slide in which the report, yeah. So this is a color chromaticity chart, and basically International Civil Aviation Organizations has defined this graph in Annexure 14, and they have defined some areas. So they have defined an area. So this is, supposing this is the white area. So anywhere in this white area, if your color chromaticity is falling, X and Y coordinate, your fitting will pass ICAO. But if it is falling outside this graph, so it'll fail. So basically, X and Y coordinates are basically mapping which exactly point is coming on the color chromaticity chart, and whether it is compliant to ICAO or not, because ICAO is quite strict about the areas, and they have even gone to that extent that they have defined a different color chromaticity chart for halogen and a different color chromaticity chart for LED. So your X and Y coordinate should fall under that area only. And this testing, chromaticity testing, can be done using equipments if they have a chromaticity sensor to give this output.
The next question from Mr. Amit Goyal. For cleaning purpose, you suggested baking soda, but caustic soda has much better cleaning property. Then why it is not used?
Basically, there are two types of these things are used. One is baking soda, and there's another uh, raw material also. I don't remember what exactly it is, but baking soda is actually used because it is widely available. Even I've seen this OEM heavy technology in Paris. They are doing this photometric testing. It's basically a French-based company, and they're using Tata baking soda only in Paris also. So they're procuring this baking soda, which is manufactured in India, as a raw material, which means it is widely available. So they feel that since it is already made by Tata, it is widely available in India. So they have used that. But in any case, I can check this with the manufacturer if anything else can be also be used, like he has pointed out. But it's the OEM who has decided. It's not I who has decided which raw material has to be used. It is recommended by the OEM.
The next question from Mr. Manish Sharma. What is CCR?
CCR is a constant current regulator. So basically, in airfield lighting, all the lights are powered through a constant current regulator. Basically, it's a transformer which gives a constant current output. The reason is it is not the lights are not voltage driven, because the CCR hall is far from the runway, because in runway you cannot have any obstruction, so you cannot have a building near the runway. So it is quite far from the runway. And if you use voltage driven lights, as an engineer, I'm sure you'll understand that whenever the voltage, there's a voltage drop whenever on the cable because of the resistance of the cable. So if they are voltage driven, the pilot will see different light output on every light when it is landing and taking off, which should not be the case. All the lights should illuminate at exactly same illumination level, and human eye cannot detect it. Only a photometric testing machine can do it. So if you see voltage driven lights, you will see a different color chromaticity output, basically output candela, in comparison to current driven. So in series, the current is exactly the same. So as long as it is the same current, the light will also all glow together at the same intensity, which is why CCRs are used to power these lights at a constant current.
Thank you, sir. Thank you for this knowledgeable presentation. It will help us all greatly. We would like to also let you know that ICAT is currently serving the airfield lighting industry by carrying out photometry, mechanical, and electrical testing as per ICAO Annexure 14 and FAA regulation. ICAT has a wide experience of testing over 500 airfield samples, providing strength and safety to the Indian aviation industry and Indian skies. Thank you all for joining today. We will share feedback form to your email IDs, and kindly fill the same and revert back to us. Now, I would like to invite Dr. Anoop Kakkar from SAE NIS Coordinator. We welcome you, sir. Oh, sir. So, you are not audible.
Sorry.
Okay.
Yeah. Namaskar and good afternoon, one and all. Thank you for supporting this conference, which has been organized by ICAT in association with SAE NIS under the mentorship of Mr. Dinesh Tyagi, Chairman SAE NIS and Director ICAT, Madam Pamela Tikku, who is the CBO ICAT, and Mr. Madhusudan Joshi, who is the Senior Vice Chairman for Seminars and Conferences. SAE Northern India section is a 20-plus-year-old non-profit, member-driven technical society. And our primary objective is to provide a platform for giving you learning opportunities. And it covers not only professionals who have joined today, it covers school students from class 5 and 6 to engineering college students to industry professionals, and you get to learn from very senior mentors, CTOs, CEOs, presidents. Now, so this is our vision, and this conference is just one small step in achieving this mission. So basically what Anshul has talked about is use of technology and how to innovate. So basically he's talking of technovation. If I can use one of the acronyms like ASPIRE, we are talking of techno-innovation, and what SANIS has envisaged in 21-22 are some more challenges in our regular event format. And we have taken up new mega events, basically to achieve a higher reach and involvement of the SAE community. And some of the major ones are that we're going to organize the first virtual autonomous challenge competition for students with a unique format of hands-on technology experience, technology display, and knowledge sharing. We're also going to organize the first 4-day virtual vehicle handling conference at ICAT. And the industry partners will get an opportunity to showcase the technologies in this area. We also have 2 flagship events. One is the 4-day thermal management conference, and there's also a summer school for automotive technologies. Besides this, there's an event happening in ICAT, ITEC 2021, in collaboration with IEEE of USA. And the theme of this year's conference is e-mobility for Atmanirbhar Bharat. That is sometimes in December 21. For school students, we have a competition, A World in Motion, AWIM. For engineering students, we have FE-Cycle, we have Supra, we have Baha, all design and demonstration of different kinds of vehicles. All of you have been strong partners of SAE, and you have supported us both by providing experts on various subjects in mobility value chain, like we have Anshul today, volunteers for judging the competitions like FE-Cycle, Supra. You have given experts for conducting technical lectures for engineering colleges and making them aware of what is likely to come in the emerging technology field. But why are we doing this, and what benefits you will get in case you become a member of SAE? And the most important is, since all of you are technocrats, you have access to e-magazines, either Automotive Engineering International or Aerospace Engineering magazines from SAE International USA. And these will be available to you at the click of a button. Members will also get subscription to Mobility Engineering magazine, which is an SAE India, which is our parent body and SAE Northern India section is one of the 4 sections of SAE India. And you have free access to SAE international papers presented in various conferences. Besides, the revenue advantage is that you get a discounted price to SAE top events. Like this one is free, but this one is free for all. But normally we provide free programs for SAE members. Then you have an opportunity to connect with academia and students and share your experiences and learn from the creativity of the young minds. And most importantly, you get an opportunity to network with industry leaders and corporate officials. SAE India is your association and it is run by you. So we will therefore request professionals like you and a team to be, let's say, a part of this platform, which will help us deliver quality technical and learning programs through conferences, events. And in conclusion, let me give you a small story of a very famous athlete, Usain Bolt. All of you may know that Usain Bolt won 9 gold medals in 3 Olympics. But the total time he ran was 115 seconds. And the revenue that he got was $115 million. So for each second that he ran, he earned $1 million. But to run that 1 second, he had to make or practice for 20 years. And that was the investment he has made, which made him earn $1 million. So if you all become SAE members by investing, say, 10,000 rupees plus taxes and getting a 10-year membership, the learnings, the knowledge that you will be getting, there is no price tag to it. It is priceless. Like what I learned today was something which I used to see since the time I have been flying. But then how these things are managed, how these things are handled, how these things are repaired, and how the downtime is reduced and how efficiency increases. I mean, these are the things and opportunities that you get when you get associated. So there's a handout given to you which has a overview of SA and IS activities, which broadly I have covered, which has the benefits, and I would look forward to your getting associated with us so that you get to. We had recently 2 more events over the last week, 10 days. One on functional safety and one on one more event. So with these, let me tell you in 2 lines what I am. I retired from Indian Oil in 2011 and I have been associated with SAE Northern Sections in 2013. And for me, it has been a big learning experience. And through the SANIS platform, it has thrown up challenges, but every challenge also has given me an opportunity to learn something new from each one of you. And I have been sharing my experiences, my learnings, my failures with professionals, with students. So I look forward to meeting you all again and getting associated. My contact details are in the handout. Anybody wanting to get associated, please drop in a line to me and we will see that we support you. Thank you so much. Once again, namaskar.
Thank you, sir. Thank you for this knowledgeable session. Thank you all for joining today. We will share our feedback form to your email IDs and will revert and kindly fill the same. We'll revert you back. Now stay healthy and stay safe.